Hey guys, this is Booty Noob here with another episode of CECS 225. This assignment was on multipliers. We had to do a 2 to 1 multiplier, a 4 to 1, and an 8 to 1 multiplier with their 10th bench code as well. So let's go through this quickly. It's pretty late. Uh, so here we have the code that Dr. Nachawati had given us. The mux 2 to 1. We have two inputs for a standard multiplier and a selector with an output of y. And what we do here is we assign this y to be uh, an input and a selector. The selector can either be a 1 or a 0, uh, or the output of not the selector, so the opposite of the selector, and another input. So once it does those two, it's going to do an AND gate here, an AND gate here, and an OR gate between both of them, both these outputs, whatever they come out to be. And the test bench for this looks like this. We have APS and a wire O. What we do is call the mux to the 1 design code, and we map uh, these failures A to A, B to B. In this case, this should be S. No worries, I've tested this several times already. And then O. Alright, and this honestly is for the timing diagram. Okay, we can show it if you like. But all it really does is sets the A to 1, B to 1, S to 0, and S to 1 as well. Because selector can either be both of them, right? Okay, that's what this timing diagram would do. Okay, and that's what mux 2 to 1 would do. Now, mux 4 to 1. What Dr. Nachawani asked us to do was to cascade mux 2 to 1 muxes. Okay, the modules. So what I wanted to do, or what I eventually did, was I had 4 inputs because a mux 4 to 1 means 4 inputs, 1 output, as you can see. I had 3 selectors, one for these 2 inputs, another for these 2 inputs, and another one for a last mux, as you'll see right now. So what I did was I called the mux to the 1 module that I have here given. I mapped 2 inputs and a selector, and the output would be a wire. Okay, same thing for this one. 2 inputs, a selector, and the output would be a wire. And so what we would do is that we would get the outputs of these 2 wires and map them to a final input, another final input, get another selector, and get our final output. Okay, because if we would just have these 2, then there's no other way of comparing what the output would actually be. So that's why we need another multiplier to actually compare what the outputs would be here. The test bench for this looks like this. We have 4 regulars, 3 selectors for me, and a wire. Okay, it displays mux 4 to 1 tester. All we do is map each and every one, alright, with their respective values here. And what it's going to do is going to go through this for loop, starting from 0 all the way to 4. So 0, 1, 2, 3, incrementing 1 each time. And it's going to vary by I, the integer I. This integer I is going to be set to each of these selectors respectively. And it's just going to display this little message here with I, what the current I value would be, the current D3, D2, D1, D0, S2, S1, S0, and Y value would be. It's going to do that again 4 times, starting from 0, 1, 2, and 3 for each of the inputs, basically. That's that test bench code. And going to have here the mux 8 to 1. So we were supposed to cascade 4 to 1s. Again, what I eventually had to do was cascade 2 4 to 1s and then an AND 2-to-1 so that I can compare the last two. So same thing how we saw in the 4-to-1. I have 8 inputs, one selector for each of 2, so that means 4 selectors. Okay, plus one more for this last mux 2-to-1. Okay, so I map again each one, A to A, B to B, whatever. S1 to the selector, and again, so just think about it. We're calling the mux 4-to-1 module, which in turn is calling the mux 2-to-1. So basically, these are going to be a bunch of mux 2-to-1s modules, all bunched up to make up if mux 4-to-1. And this AND mux 2-to-1 again to just compare the last two outputs here. Okay. The test bench is basically the same thing as the test bench for the 4-to-1, except with 4 extra inputs. Okay, but basically everything else is the same. The for loop is still the same. Now we're just going to display the 4 extra inputs here. And that's about it. So let's see the schematic for this thing, just so we have an idea of what it looks like. Should be correct here. Schematic come up. Okay, so here we can see the A2-1. I'm going to show you all three in the same at the same time. So as you can see, here's my 2-to-1 and here's my 4-to-1s, which in turn are 3 mux 2-1 modules. Okay, so we have 4 inputs, again 4 inputs for each, one selector for each of these, another one for here, another selector for the last 2-to-1 that you'll see right now in a sec, and this selector here for this 2-to-1 multiplier. So let's expand these so we know what we're looking at here. Give us a sec here. It is pretty big, so it's going to get pretty small. So here's expanded view. Okay, so you can see, wrong way. Maybe not that close. There we go. Okay, so this is my 4-to-1, essentially. This is my 2-to-1, essentially. Okay, so my 2-to-1, you can see 2 inputs and selector. Goes to the AND gates, inverts this one so we can have both 1 and 0, and then an OR gate here. Okay, and the OR gate at the end. Okay, and for the 4-to-1, what we do is just 4 inputs, a selector for this one, a selector for the bottom one, and a selector for this last one. Okay, so you can kind of see where we're going with this. The A2-1 would basically be this one and this one combined, stacked, with a 2-to-1 comparing these last two outputs here, this one and this one respectively. And those two outputs go to A and B with another selector, which would be selector 7. And my final output, Y. Alright, so if we run this to see what the timing diagram would be, I already ran it, so here we are. We have all our inputs, our three, our 5 or 6 selectors, and an output Y. As you can see, it's pretty messed up. It's pretty hard to see the differences, but you can see some differences here. You can see a high signal of 1, a low signal of 0, high signal of 1. All right. We see our hexadecimal values here as well. Okay. As here, it looks like this one was a high, this one was a low, this one was a high. So it works pretty good, including our selector right down here. Okay, 0 and 1. So we can see the difference it actually makes in our schematic, and that's basically it for these modules. Okay, this one is a long project, so make sure to like and subscribe to this video. See you next time.